Hi guys, welcome back. This is part 2 of the automatic temperature control project with Arduino using Flowcode. In part 1, we designed the circuit diagram. In this part 2, we're gonna start with the code. We're gonna start a new project. Under the chip target, we're gonna select the Arduino. Under the family, we're gonna select the Arduino Uno R3 pdi-p. Click OK. The first thing we're gonna add the component that we're gonna use. We're gonna need an LCD. We're gonna use the 16x2 generic LCD A23D. We're gonna need a keypad. We're gonna use the 3x4 keypad A23D. We're gonna need 2 relays. If you don't know where to find the component that you're looking for, you can search it. Search for relay. Okay, we're gonna use this one, A23D. A relay is basically a controlled digital device capable of switching much higher voltages and current than the normal microcontroller output pins. The maximum current for a single output pin of an Arduino is limited to 40 mA. Beyond this, you can start damaging your board. The Arduino board can source only a total of 200 mA. So if you want to switch high voltage and current, such as controlling a heater or a fan, you clearly cannot use directly the Arduino pins, as you could damage the Arduino. We're gonna use a relay. We're gonna need a second relay. And lastly, we're gonna need an analog sensor. That the input, we're gonna use this potentiometer. This will allow analog values to be read on the analog pin of the Arduino. The next thing, we need to specify to which pins of the Arduino we're gonna connect our devices. From the circuit diagram, the RS pin of the LCD will be connected to Arduino digital pin 2, the LCD enable pin to A5, and the LCD data pins to A4 to A1, the analog sensor to A0, the heater to digital 4, the fan to digital 3, and the keypad columns to digital 11, 10, and 9, and the rows to digital 8, 7, 6, and 5. We're gonna start with the LCD, the RS to digital 2, the enable to A5, the data pins to A4 to A1, the keypad, select custom pins, column 1 to digital 11, the analog sensor to analog 0. We're gonna rename it LM35. VREF, gonna say 200. Let us add some few labels to distinguish between these two relays. From the shapes toolbar, select label A23D. We're gonna add 2 labels. The first one, we're gonna rename it relay heater. You can also change the color. Let's change the color to white. The second one, we're gonna rename it relay fan. The color to white as well. So the first relay, we can also rename it to relay heater, and we're gonna connect it to digital 4. The second relay, relay fan, to digital 3. The first thing, we're gonna display a welcome message on our LCD. We're gonna display automatic temperature control. So let us initialize our LCD display. Start. When we start our project, we're gonna switch off the heater and we're gonna switch off the fan. Heater, switch off. And the fan, we're gonna switch it off as well. LCD cursor, gonna start our message, position 4. Gonna display on the first line of the LCD. Print string, automatic, and on the second line, let's switch to the second line first. Temp control. Gonna display this message for 2 seconds. Okay, let us run. Automatic temp control. So far so good. After 2 seconds, we're gonna clear our screen. Then prompt the user to enter the reference temperature. LCD clear. Then gonna prompt the user to enter the reference temperature. Print string. Enter temp ref. Press the H key to end. Okay. Because we are using a 16 by 2 line LCD display, it can only display 16 characters per line, and enter temp reference, press H key to end is more than 16 characters. So we're gonna display the first part of the 16, then we're gonna scroll the screen to display the remaining part. So the first part is gonna be displayed, let's say for 2 seconds. I think it's gonna be enough to read. Then we're gonna scroll the display to the left so that we can see the remaining part of the message. Scroll display, we're gonna scroll it by 16 position, and the direction is gonna be to the left. Left is 0 and right is 1. 0. And this part of the message, we're gonna leave it on the screen for 2 seconds. Then we're gonna scroll back to the original position. LCD scroll 16 position. There's gonna be 1. Then move the cursor to the second line. Second line, we're gonna display temp ref. LCD print screen. temp ref. So the next thing, we need to read the value of the reference temperature from the keypad. Gonna need a loop. In this project, we're gonna accept a reference temperature of up to 2 digits, so it's gonna display from 0 to 99. So we're gonna need to loop until we've got 2 digits, or if the enter key has been pressed. So I'm gonna need 2 variables. One is gonna hold the reference temperature, and the other one is gonna count until we've got 2 digits. Let me declare those 2 variables and initialize them to 0. And the first one, we're gonna name it count, and it's gonna be a byte variable. The second one, we're gonna name it ref temp. It's gonna also be a byte variable. It's gonna be 0. Gonna initialize it to 0, and the count variable, we're gonna initialize it to 0 as well. I'm gonna loop until 2 digits or the hash key has been pressed. We're gonna test our loop at the end. So while count is less than 2 and key, the key is gonna be a variable that is gonna hold the number that we're gonna press. So let me declare a new variable. We're gonna name it key. It's gonna be also a byte variable, while key is not equals to 11. When you press the keypad, the star key is gonna return the numerical value of 10, and the hash key is gonna return the numerical value of 11. Okay, so we're gonna read our keypad read and get the number, and we're gonna store this number in key. Then we're gonna check if this number if key is less than 10, it means we have pressed any digit beside the star or the hash key. Just write a comment here, add new digit, ref temperature is gonna be equals to ref temperature times 10 plus key. We're gonna also increment the value of count. Count is gonna be equals to count plus 1. Shift the cursor. Then we're gonna display the key pressed. Gonna print number, reference temperature. We must also wait until the key is released. So here we're gonna wait for key to be released so that we can only consider one key pressed. Gonna need a loop. We're gonna remain in this loop until the key is released. Once you release the key and no other key is pressed, the value of the key is gonna be 255. So we're gonna remain in this loop while the key is not 255. Get number, return key. Once we are done, we're gonna clear the screen. Then we're gonna display the value of our reference temperature and prompt the user to continue. Temp ref print number, temp ref, second line, press the H key to continue. Then we're gonna wait until the H key is pressed. So while key is not equals to 11. Keep it, get number, and return key. Then we're gonna clear the screen. Okay, let's run our project again. Automatic temp control, enter temp ref, scroll, press H to continue. Gonna enter 13, temp ref equals to 13, press H key to continue. Wonderful. As you can see, our flow chart is getting longer and longer, and if you want to set up our reference temperature while the project is running, then we'll have to write again the same piece of code. So the easiest way is to use a macro. A macro is basically a section of code that can be used and reused in a project. Macros allow complex tasks to be handled by code blocks, and they can be imported and exported. A macro can basically be considered like a function in C language. Instead of writing the same code over and over again, you can just write it once and call that function when needed. This is the icon of a macro. We're gonna create a new macro. We're gonna name it setup temp ref, add new, setup temp ref, so we're gonna cut this section of the code and paste it inside our macro so that we can be able to call it whenever we want. Cut, Control V. Okay, now we're gonna call this setup temp ref macro. We're gonna start reading our temperature. So we're gonna create a new macro. We're gonna name it read temperature, add new, we're gonna read the analog voltage, LM35 get voltage, and the return value we're gonna store it in a float variable. So let us declare a new float variable. New, we're gonna name it analog value. It's gonna be a floating point variable. Then we're gonna convert this analog value to temperature. We're gonna need another variable. We're gonna name it temperature. It's gonna be also a floating point variable. Temperature gonna be equals to use the mathematical function to multiply two floating point variables. Analog value, we're gonna multiply it with 500. This because the output of a LM35 is 10 millivolt per degree Celsius. We're gonna need another string variable. We're gonna name it temperature string, and the size of this array is gonna be 4. It's gonna be a string. Then we'll have to convert this floating point variable into string. These are string manipulation functions. Float to string temperature. LCD cursor. Then we're gonna display temp ref on the first line of LCD. Temp ref display number. Gonna display the reference temperature, and on the second line we're gonna display the current temperature. Cursor. Print string. Print string. Then we're gonna display the degree symbol. Print ASCII 223. Different LCD displays have different character code for the degree symbol, so you must check your datasheet for more information. And lastly, we're gonna display the C character. Print string C. Let's run again. Automatic temp control. The reference temperature is gonna be 26. Enter. And this display on the first line temp ref goes to 26, and the current temperature at the moment is 0. I can change it. Okay, the simulation ended because you must always not allow your main loop to exit. So I'm gonna create a while one loop. Okay, we need to read continuously our temperature, so we're gonna insert our read macro inside the while one loop. Let us run. The reference temperature, we're gonna set it to 29, and now it's displaying the current temperature to be 149 and the reference temperature 29. So I can change the temperature. Okay. The last thing in this project, we need to compare the temperatures so that we can decide whether to switch on the heater or to switch on the fan. We're gonna need another macro We're gonna name it compare temp. Here we're gonna have a if statement. If the reference temperature is greater than the current temperature, then we're gonna switch on the heater and switch off the fan. Heater switch on, and the fan we're gonna switch it off. We're gonna decide again if the reference temperature is the same as the current temperature. We're gonna switch off everything. The fan is gonna be off, and the heater is gonna be off as well. And lastly, if the reference temperature is below the current temperature, then we're gonna switch off the heater and switch on the fan. Heater is gonna be off, and the fan is gonna be on. Okay, let us run. Set it to 28. The reference temperature is greater than the current temperature, so the heater is on. Now increase the current temperature, then the fan is on and the heater is off. Let us save our project. Save. Automatic temp control. Let us compile to hex to generate an X file that can be loaded to the Arduino board. Compile. Finish successfully. Let us simulate the project in Proteus as well. Run. Automatic temperature control. We're gonna set the reference temperature to 23 degrees Celsius. Press the H key to continue. You can see the current temperature is lower than the reference temperature. That's why the heater is on to warm up the area. If the temperature increases, let's say above the reference temperature, you can see now the heater is switched off and the fan is switched on to cool off the area. And that's all guys for this tutorial. In part 3 we're gonna add the EEPROM to store the reference temperature so that each time you switch on the application you don't have to enter a new reference temperature. It can be read from the EEPROM. We can also enable the setup menu in operation. So if you press and hold the start key for more than 3 seconds, it will prompt you to set up a new reference temperature. We can also see some other features that could be added to improve the code of this project. Thank you guys for watching this tutorial, and I'll see you guys in part 3. Thank you.